Okay, so now we can consider hydraulic systems. Okay, basics of how hydraulic systems work. Everything that we've seen thus far allows us now to understand how hydraulic systems work and how they're very helpful. And here's an example of a hydraulic system where you've got basically a connected system, right? The fluid is connected between this piston and that piston. And as you can see, this area over here is smaller than that area, that cross-sectional area. Okay, and usually in hydraulic systems, like for example inside a car, you use hydraulic fluid or kind of oil, which is incompressible. What does that mean? It means that if I apply a force over here, then that pressure is transmitted right throughout the fluid. Okay, so because oil is incompressible, a force exerted on one piston increases the pressure everywhere in the oil, and so the force is transmitted to the other piston. Okay, now this is seen, one of the best applications is in a car, where if you're driving and you press the brake pedal, then this mechanism applies the pressure into a master cylinder. So everywhere over here inside this whole system, we've got our brake fluid, right, this oil, and as you apply the force over here, it increases the pressure and transmits that pressure throughout the fluid right to wherever you have brakes on the car. Okay, so it's very helpful because you apply a small force over here and it basically slows down your entire car. Okay, now how does this work? Well, let's consider this diagram over here. Again, we have a system over here where we've got a container with a piston, and here we have another container, and they're connected. Okay, and this area over here, notice again, this area over here is smaller than the area there. Okay, and because all the pressures on the horizontal line are the same, we know that pressure 1 is equal to pressure 3. Okay, pressure 3 equals pressure 1, and we know that pressure 3 equals pressure 2 plus rho g h. Okay, so if we rearrange this, we can say pressure 2 is pressure 3 minus the density, gravity, and h. But we know that pressure 3 is pressure 1. Okay, so we can say this, P1 minus rho GH. So pressure 2, pressure over there, okay, the pressure that's applying an upward force on something, okay, is the pressure over there is equal to this pressure 2 is equal to the pressure 1 minus rho GH. Okay, but in real life, the density of oil, according to the textbook, if you read on, is very low, and this height inside a hydraulic system, okay, is very small. So this is basically 0. So P2, pressure 2, is the pressure at 1. Well, approximately. Okay? The pressure at 2 is approximately the pressure at 1. But now, I hope you're still with me. Remember, what is the idea behind this? The idea is that I'm applying a force here, and it's transmitting the force somewhere else. Okay? But now the pressure at 2 is equal to the force 2 over area 2, and this is equal then to the pressure at 1, which is force 1 over area 1. Okay? Is that making sense? Pressure is force over area. So, if I'm applying a force 1 what is the force that is being applied over here? The force, so force 2 is A2 over A1 times F1. So you are multiplying your input force. Okay? You apply a force with a smaller area 1. Okay? And then it gets multiplied. This F2 is then A2 over A1. If A2 is larger than A1, then you are multiplying your input force and you're getting a larger output force there, F2. Does that make sense? Okay. Let me see if there's anything else here. That is the idea that we're getting there. Okay, so that factor, A2 over A1, is what permits you to exert large forces on the brakes of a car, even though the force your foot exerts on the pedal is relatively small. So it takes a small force and it multiplies it by this factor and can actually apply a force to slow down your car.